KPIT STEM Dialogues, which is what we are launching today, is the fourth step in this regard. So here is the first edition of KPIT STEM Dialogues, and we are very happy that to launch this first edition, we have with us Dr. Mashelkar as our first speaker. In India, Dr. Mashelkar doesn't need much introduction, especially to the science students. But I think a formal introduction is in order because of the phenomenal work that he has done in the field of science and technology. Dr. A Mashelkar is a world-renowned scientist, known for his extraordinarily transformative work in the field of scientific institutions. He has also been known for his penchant for innovation. He is a Padma Vibhushan as well as a Padma Bhushan and a Padma Shri, all the three very high awards that are given by the Government of India. He has been the Director General of CSIR and has done many areas of research in that. He has been associated with a very large number of academic institutions, being their Vice Chancellor. He has received a record of 45 honorary doctorates from institutions all over the world. He is a jury member for the prestigious Queen Elizabeth Prize for Engineering, which is considered as equivalent to the Nobel Prize in Engineering. He has been elected as a foreign associate for the US National Academy of Engineering. He is a fellow of Royal Academy of Engineering. He is also a member of Australian Academy of Sciences and a fellow of the World Academy of Arts and Science, USA. He is the only third Indian engineer to have been elected to the Fellow of Royal Society since 1660, the seventh Indian scientist to have been elected as a foreign fellow of the US National Academy of Science, and the seventh Indian to be elected as the foreign associate of the American Academy of Arts and Science since 1780. He has been a member of the External Research Advisory Board of Microsoft, of VTT Finland, of Michelin, and Advisory Board of Prime Minister's National Research Foundation for Singapore. Dr. Mashelkar's connections with international academic education and research community are deep and wide across universities across the world. He was a visiting professor at Harvard and at Delaware, at Technology University of Denmark, among other institutions. He has been on the board of directors of several reputed companies such as Reliance, Tata Motors, Hindustan Unilever, Thermax, KPIT, Godrej, etc. He has been propagating a culture of innovation and balanced intellectual property rights regime for over 3 decades. It was through his sustained and visionary campaign that growing awareness of intellectual property rights has dawned on Indian academics, researchers and corporates. He has helped the government in multiple areas of their scientific and administrative problems. Actually, there have been 16 Mashelkar committees to address different issues which the country has faced over the years. In the post-liberalized India, Dr. Mashelkar has played a critical role in shaping India's science and technology policies. He was a member of the Scientific Advisory Council to the Prime Minister of India, set up by successive governments for a long period of 30 years. He was also a member of PM's National Innovation Council. He pioneered the concept of Gandhian engineering, getting more from less for more. His paper on this subject, co-authored with C.K. Prahlad, has been named among the top 10 must-read papers in innovation. He co-authored a book with me titled Leapfrogging to Pole Vaulting, Creating the Magic of Radical Yet Sustainable Innovation, which won actually the Best Business Book of the Year award in the Tata Literature Festival. Dr. Mashelkar has been contributing to the social causes all his life. He has chaired the corporate social responsibility committees of Reliance, Tata Motors, Godrej Agrovet, etc. Ladies and gentlemen, it's my pleasure to present to you Dr. A Mashelkar. You have been the Director General of CSIR for a long time. You have also been on the board of directors of many companies, reputable companies across the globe. And you have led their science or innovation foundations. So you certainly have a very broad spectrum of the field of science that is emerging. What I would like to ask you is that which are the 4 or 5 areas of scientific development which you think are going to be highly impactful over the next 25-30 years, which we can consider as the lifespan for this of working of this generation. Which are those 4 or 5 areas which are going to impact India and the world over this period, and what should they do to get themselves ready for it?
Thank you, Ravi. First of all, I want to profusely thank you for two things. First, starting this STEM dialogue, and secondly, doing me the honor of being the first to participate in this dialogue. Now, your question about new technologies that will sort of come. There are existing ones and there are rapidly emerging ones. Now, among them, I will single out a few. I think the first is going to be biology, but more importantly, new biology. You know, after Watson and Crick found out the structure of DNA, the word changed, as a matter of fact.
Yes.
And therefore, we started talking about gene therapy and all these advances, etc. But over a period of time, what has happened is that there have been some breakthroughs in new biology, like synthetic biology.
Yes. Yes.
Like, for example, new tools that have come up. Like there is this tool called CRISPR-Cas9. So if you look at human genome, it took us more than a decade and $3 billion to crack the genome. $3 billion. Today we can do it for not just $300, $100.
Yes.
$3 billion to $100. So as a result of that, this tool is in everybody's sort of hand, so as to say. It is affordable. And then what has happened is that previously we read the genome. Now we can write the genome.
Yes.
So as to say, we can make correction. Now CRISPR is like a Caesar.
Yes.
It can cut, paste, adjust.
That's true.
So what it means is that it can repair genes, for example, and some of the diseases like cystic fibrosis don't have to be there because they are there because of some malfunctioning. You can start correcting it.
Yeah.
But at the same time, you will find that the new challenges that we have, these techniques can be used. For example, take climate change. You will see the kind of variations that we are going to have in terms of high temperatures, very low temperatures, all sorts of adverse conditions. And the plants have to be grown, agriculture has to survive under these conditions.
Yes.
And therefore, CRISPR-Cas9, as a matter of fact, can help create plants which will be salt tolerant, drought tolerant, tolerant to all kind of stresses.
Yes.
And it's the same thing in medical science, for example. I would say, as far as the new biology is concerned, that close to 60% of the physical inputs can be created by new biology.
Yes.
You know, I mean, I don't have to tell you that because KPIT technology is based on digital technology. And we have seen advances in this, and we call them exponential technologies now.
Yes.
Because they grow exponentially in terms of the speed, in terms of reduction of cost, etc., etc.
Yes. Yes.
So whether it is artificial intelligence, machine learning, cloud, edge computing,
Or quantum computing.
Quantum computing, for example. You will have digital twins, for example, or facial recognition, IoT, for example, you know, Internet of Things, and a brain-computer interface, etc. So there are something like 25 technologies which fall under that one category. Like I said, in biology, there are sort of several. Also, what will happen is that, as you can see, we talked about 2G, then we went to 3G, 4G, in terms of power of network. Now people are talking about 6G.
Yeah.
Now, Ravi, you can understand if you are talking about 1 terabyte per second, what difference we are talking about.
Yes.
All intermittencies go, this, that, and the other, etc.
Yes. Yes.
And that will have sort of tremendous repercussions.
So I think intelligence can lie somewhere up in the cloud,
Yes.
and you can draw it in every fraction of a second. So I think
Beautifully put.
Yes.
Absolutely. So that is the power.
Yeah.
You know. And then, of course, you have this Web 3.0, for example, Web 1.2 was decentralized, Web 2.0 become centralized and few companies benefited. Web 3.0,
Yes.
finally it is going to be the hands of the people, the creators. It will be internet of the people, controlled by
Extraordinary change in the lives of everybody around.
everybody else, basically, So it's going to be huge democracies. And then people talk about augmented humanity, where personalized, every person can be technologically augmented in terms of wearables, for example. You may be wearing a smartwatch or whatever, and other sort of. So these technologies, and you will have ingestibles, for example, which can sort of tell you what's happening, the path, and all that. So I would say the first is new biology, second is sort of digital technologies in variety of forms, and they're just growing, actually. And the third, as a generic term, I would say clean energy technologies. Because we know the dangers of climate change and what danger lies ahead if we don't sort of keep that rise to 1.5 degrees centigrade, etc. All those targets are known. And therefore, there will have to be a variety of technologies, which I would call it a decarbonization in some sense. Not only just less carbon, but carbonless. If we like to put that, will be the ultimate.
Even actually carbon negative, if you can do it, because the amount of damage that we have done to the environment over the last century and a half is just enormous. Yes.
And there, of course, there are lots of technologies coming in different, whether it is production of new energy, and we already know about solar photovoltaic or wind and others.
Yes.
But also new energy forms, like for example, we talk about green hydrogen, because normally hydrogen is grey hydrogen, that we get by reforming and so on and so forth. But then blue hydrogen is one where you can actually store the carbon dioxide that gets generated simultaneously. But green hydrogen is the best because, see, for example, if you get solar electricity and that is used to decompose water in an electrolyzer, basically split water, then that is the best way of doing it. So I think there are technologies that are emerging to create that. And there is a lot of scope for improvements and achieving new targets. For example, in electrolyzers, can we increase the electrolyzer efficiency dramatically? But that will bring the cost down and so on and so forth. And then there are alternative ways we'll have to think, because, for example, when you say water splitting, 1 ton of green hydrogen will require 10 tons of water, for example. And if you are talking about millions of tons of water, where will that water come from? Because we require it for agriculture, we require it for human consumption, we require it for industry and so on. So can we look at that vast sea and say whether seawater electrolysis can directly give you water? That's a challenge. That is not made. The best thing will be the sun is shining, and if you have a photocatalysis, which actually decomposes, there is nothing like it. And that too at the room temperature. You don't have. Now, the challenge there is that the current efficiencies are only 1%. Can we take them to 10%, 15%? That requires new science again. And
The kind of thing that we had to do when we came about photovoltics.
Yes.
Changing the efficiency of photovoltaic over the last 2-3 decades.
Just see, actually I sit on the Queen Elizabeth Prize of Engineering, which is kind of a Nobel Prize in engineering. And this year, it was given to Martin Green, from New South Wales. And what did he do? We were stuck at around 14% efficiency. He took it to 28-29%. How did he do that? By creating a new breakthrough, which is called Perk cell technologies. All right. Now, in that, what you are doing is that when you hit a photon and create an excited electron, basically they used to recombine. In his technology, he made sure they don't recombine. So therefore, technology like that. So I think the point I'm trying to make, particularly to the young students, is I've just picked up 3. I can pick up more, but these are kind of technologies which are important for not only human the productivity or growth, but human survival, I would put it this
Yes.
way. And in
Yes.
each of these, there are challenges in physics, in chemistry, in biology, in mathematics, in computer science, all sorts of sciences. So it is going to be the science, it is going to be the STEM, which is going to create our new world.
I wanted to ask you now, your life has been a truly an extraordinary journey. From your childhood, where you studied under the street light, to a level that hardly 0.001% of the scientists can ever hope to achieve. You have traveled that journey over this period of time, and it's a fairy tale journey. I mean, it's extraordinary journey. What are the lessons you draw from it, and what is it that you would like to tell our audience about that journey?
Yes, thank you. Yeah, you are right. I studied under street lights. I was born in a very poor family. My father died when I was 6. I was born in a village called Mashel. That's how I'm Mashelkar. And my mother was illiterate, brought me to Mumbai in search of a job. I remember I walked barefoot until I was 12, studied under street lights, as you said. I studied in a municipal school in Marathi medium, by the way, and didn't make a difference. I want to specially give this message to all those who are studying
Yes.
in Marathi medium
Yes,
in
yes.
municipal schools. It
Yes.
doesn't make a difference.
Yes, yes.
But because we are talking about science, I must narrate a little story about how I got into science.
That would be very interesting.
Yeah.
Yes.
See, what happened was, as I said, I was in municipal school. I passed 7th standard with some 88% marks. And I was seeking admission. But what happened
Yes.
was that the fees, including uniforms and books and everything, included 21 rupees. And my mother didn't have 21 rupees. So I remember our borrowing that money from a housemaid in Chowpatty, which was her saving. She gave it, and by that time it was too late, and I missed getting admission in top schools like Wilson, Aryan, and so on and so forth. So I went into a poor school, which was meant for poor students coming from those communities. But that poor school, Ravi, had rich teachers, and one of them was my science teacher. And in life, you always have wow moments. He
Yes.
gave me the wow moment, I'll tell you. He believed actually in not just chalk and talk, but he wanted us to see and learn. For example, soap making. He didn't go to the board and write the equations, but he took us to a factory by tram those days.
How exciting.
And
Yeah.
it was Hindustan Lever, and showed us how to make the soap, right?
Yes.
From the time you take the ingredients and
Yeah.
finally packing. It was fascinating. I was just in 9th standard. And like that, Wimco factory, how to make bad boxes, etc. So what he did one day was he took us out into the sun. He had a convex lens in his hand and wanted to show us how to find the focal length. So he had the convex lens, he moved it up and down, and when the brightest spot was there, the paper burnt. When the paper burnt, he turned to me for some reason and he said, like this, if you focus, you can achieve anything. Ravi, that did two things for me.
Yes.
The first is I said, my God, science is so powerful, I must
Yes.
become a scientist. Yeah.
Yeah.
And secondly, philosophy of life. You
Yes.
focus and you can achieve
Yes.
anything, particularly for the young generation now.
Yes.
I want to emphasize,
Yes.
because you are either doing this or this. You need to concentrate
Yeah,
and
that is true.
focus.
Social media keeps us too busy.
Yeah,
We
that's
really
right.
need to defocus from
That's
that.
right.
Yes.
Yeah.
Yes.
Now, answering your questions, what I will do is that I will focus on the research that I have done and what I have learned sort of out of it. I think the first thing I want to say, particularly India is still a poor country. 70% of it lives in villages, 17% lives in slums.
Yes.
So we are still not there.
That's
All right. So India is one and Bharat is another one. And we talk about India at 75, we have to talk about Bharat at 75.
Yes.
It continues to remain poor. So therefore, when we think that because we are poor, we can't compete, we are wrong. It is not the power of budget that matters, it's the power of ideas. And still, we could do science which was ahead of the multinationals. I mean, I remember when I took over as director of National Chemical Laboratory, first day, 1st June 1989, I said National Chemical Laboratory will be International Chemical Laboratory because those were days when we were reverse engineering, we were copying.
Yes.
Anything that happened in the rest of the world, we were copying because our patent laws allowed it.
Yeah.
So we had become a copying country. There was no incentive to sort of, 91 we liberalized, opened up, and then competition came in. And therefore, whenever we did anything that was ahead of the world, the industry would say, but have they done it? Has US done it? Europe done it?
Yeah.
So I said, what am I selling knowledge? And what is my sort of market? The whole world. And it looked audacious at that time, Ravi, because this laboratory, National Chemical Laboratory, which had no US patents in 39 years, I said, we'll license our US patents to the leaders in the world. And somebody came when I gave the speech, he said, sir, do you realize that General Electric R&D budget is 2.5 times India's R&D budget? I said, no, it is not the power of budget.
Yes.
And since you talk about General Electric, we'll take on them.
Yeah.
And there is some story because of which I had some breakthrough idea of solid state polycondensation of engineering plastic that they had, polycarbonate. They were leaders in that. They had never done it. And we did it, we patented it, basically, and we licensed 3 patents for close to $1 million in 1993, showing for the first time that it is the power of ideas that matters, not the power of budget. So that's the first thing. The second is risk-taking, basically, taking adventurous ideas, because bulk of the time we follow. Somebody has done something, I have done my postdoc at, let's say, Max Planck, I come and do something incrementally. But in science, risk-taking is very important, audacious ideas, etc. So I did a number of experiments. For example, in National Chemical Laboratory, I created a kite flying fund. Kite flying means idea 1 in 100.
Yeah.
So let your imagination be wild. Think of what is impossible and try to make it possible, etc. Failure is something that we worry about in India. But I describe fail, F-A-I-L, as first attempt in learning. All right. So risk-taking is very important. The other thing is borderlessness, because we say chemistry, biology, etc. But the new word is going to be borderless. In fact, I have a lecture called P.V. Dancourt's Memorial Lecture on borderlessness and how the different borders between science, different sciences are sort of disappearing. Between engineering and science are basically disappearing. A lot of my work is on borderlessness. Yes. For example, I was a visiting professor at Harvard and we had multidisciplinary sort of interaction. For example, you know, when you take a cancer drug, you don't know how it is working because then every month you take some indirect measurement and find, no. What a magic it will be as the drug is working, you can come to know. We have a breakthrough paper in Procedure of National Academy of Sciences. But you know, 7 different disciplines came together.
No, I think interesting things happen at the intersection of different sciences. That is where extraordinary insights can come.
Yes. And I remember when I gave that lecture in London, my mentor Ashok Ganguly, who was Unilever's research director, came because he couldn't attend the lecture, and he said, can you describe in one line what is the lecture you are going to give? You got challenge. He always challenged. And I say learning to dare and daring to learn. Because when you look at different disciplines, basically, you know, daring to learn from those and then create ideas. So that is one more lesson. The other one, which is very important, is particularly for India, is that we have a lot of poor people. And therefore, making low technology work for the poor is very easy. Making high technology work for the rich is very easy. How do you make high technology work for the poor? So inclusion is very important. So can you do the science that helps the poor, as a matter of fact? So I think in brief I would say that power of ideas, not budget. No difference between scientific and industrial research. Science is application. Inclusion, most important. Risk-taking, most important. And thinking borderless. I would say my own science is these 5 lessons.
So, Dr. Mashelkar, I have been very closely interacting with you and seeing you for many years, and I find it fascinating that at the age of 80, you are so active. And looking at you and seeing what you do is inspiring. What I would like to hear from you, what does a day in the life of Dr. Mashelkar look at, or what does a week in the life of Dr. Mashelkar look at? How do you utilize your time? What takes you, what takes chunks of your hours?
Yes. Yeah, it's very interesting. Since you talked about a week, let us talk about the last week. I'll give you an account in 2-3 minutes about what I did. Last Sunday to this Sunday, basically. I was in Sangli to give these very important awards, Karmavir Bhaurao Patil sort of awards. As you know, he was a great individual who brought educational transformation.
Yes, the Rare Shikshan
Yes,
Samstha.
and I addressed some 1,000+ students and so on and so forth. So I had to tell them that, look, you don't have control on where you are born, to
Yes,
whom you are born,
yes,
on what
yes.
day you are born, to
Yeah.
which parents you are born. But your destiny is in your hands. And you can be another Mashelkar plus. So I took them
Yes.
through my journey.
Yeah.
And I also told them about India at 75 and Bharat at 75. And I said we must dream of not just India at 100, but Bharat at 100, basically. And then I gave them sort of a idea of what Bharat at 100 of my dream is concerned.
I see.
So, like Santulit Bharat, Susavskrut Bharat, Samruddha Bharat, Sushasit Bharat, Surakshit Bharat, and Swanandi Bharat, internal as well as this.
Yes.
So that was my talk.
Yes.
The following day,
Yeah.
I've been Sir Louis Matheson Distinguished Professor at Monash University,
Yes.
which is one of the most reputed in Australia, and I spend every April there giving some general lectures. So this idea of IIT Bombay Monash Research Academy came up, basically, and I have been its chairman almost from its inception, excepting for the first 3-4 years. And we have just given the 200th PhD, and that's a very special academy. So there is the advisory council. I have been the chairman of that. So the following day, I did that.
Yes.
The following day, I'm doing a book called Experiment. Experiment is exponential improvement.
Yeah.
And
yeah.
exponential improvement by converging the parallels. The seemingly unconnectable, you have breakthrough. It's like
Yeah.
this, Henry Ford started
Yeah.
manufacturing of cars, but they were very expensive. Then one day he went to slaughterhouse and found how the animals after being cut, the meat packaging was being done in an assembly line approach. So he said, if that can work here, why can't
Why
it?
not? Yeah.
And he started in auto manufacturing the assembly line.
Yes.
And
yes.
after that, the cost dropped so much, and that is how we
That's
have the
true.
car.
That's true.
Now tell me, what is the similarity between slaughterhouse and car manufacturing?
Yes.
He connected those dots.
Yeah.
So the entire book describes how breakthroughs in science, breakthroughs
Yes.
in technology have come.
Yeah.
So
Yeah.
this will
Yeah.
come. So I was just doing some work on that book, final finishing stages. Penguin is going to publish it. The following day, there is this Geo Institute that has come up. Mukesh Ambani is bringing up this again as a kind of a next practice laboratory, and we have started courses on that, on digital media, marketing, communications, artificial intelligence, data science, etc., etc. And we wanted to select the chairman of the computer science. So I spent time in interviewing him. The following day, for innovation, we have this public procurement, which is a big bottleneck in India. So I'm writing a paper with Dr. Ajay Shah, who wrote that book with Dr.
Yes.
Vijay Kelkar.
Yes, yes,
He's a
yes.
master of policy. So in the morning
Yes.
I spent there. And evening, my alma mater, I'm very proud to say that one of the greatest honors in engineering is election to US National Academy of Engineering.
Yes.
So far, there have been 2,000 plus NAE fellows, out of which only 1% comes from India.
Oh.
But out of which 25% come from one institution. and one chemical department. That is of my
Yeah.
alma mater.
Yeah, yeah.
So 6 of us are there. So I chaired that sort of celebration. It was a proud moment. The following day, I flew to Nagpur, 4:30, getting up in the morning and taking the early flight, because there are these awards that have been created, uh, and one of them was in my name, basically. So I attended that sort of function for research. Then yesterday I was with you. KPIT, we had our
Yes.
Sparkle program, and we
Yes.
honored research,
Yes.
innovation,
Yes.
and
Yes.
saw young entrepreneurs. So these are my 8 days, basically. Now here you can say my role as an
Yeah.
academician, as involved in industry.
Yeah.
So somehow or the other, I've learned to sort of optimize time.
Yeah,
I'll put it.
yeah, yeah, yeah. That is interesting. That's interesting. In this life of really unique achievements, what do you see as your dearest achievements, as well as your moments of despair?
Oh yes, excellent question. Let me come to the happy part first. See, what happens in science, the highest award you can get is Nobel Prize.
Yes.
After that, there is called what is called as FRS, Fellowship of Royal Society, and US National Academy of Science. I've been fellow of both. But FRS is something very special, because what happens is that you sign in the same book that Newton has signed. And you do it in the same way that he did, by the way. In fact, there is an ink pot, like the old ink, and then, because we are all ball pen guys,
Yeah.
so they make you actually practice.
Yes,
And his
yes.
signature is on the page 9, by the way.
Yeah,
And
yeah.
everybody looks at it.
Yes.
Because every fellow is given his wish.
Yes.
Who do you want to see?
Yeah.
So, so it is laminated.
The British have a wonderful way of guiding, kind of keeping their traditions.
Absolutely, absolutely. Now the interesting part is that I am an
Yeah.
engineering scientist. You would ask, in 360 years, how many engineering scientists have got this honor of signing in the same book? Only 3. One of them is my guru, Professor M.M. Sharma. Another one is Ruddam Narasimha, is no more.
Yes.
And third is me. So only 2 living scientists are there today. And I'm both happy as well as sad. I'm the only Maharashtrian to have signed in that book so far. Happy because that is unique, but sad because there should be 10 other Mashelkar. But anyway, that's a separate. So that was 1998. But that 1998 was also a special year, because within a month I got the J.R.D. Tata Corporate Excellence Award.
Yes.
I'm not a corporate,
Yeah.
but the corporate decided that I should get that award. On that day, 3 technology events happened, including the Pokhran 2.
Ah.
You remember?
Yes.
And in the morning, there was an achievement by DRDO in terms of a missile. So I mentioned to Murli Manoj Joshi, Professor Murli Manoj Joshi, who was the minister of that, we should sort of call it a technology day. Just as we have C.V. Raman,
Yeah.
Nobel Prize, 28 February, Science Day. And one thing led to the other, and finally Atalji declared it as a technology day.
Oh, what an achievement.
What a 1998 year. Whether it is by personal science,
Yeah.
recognition by industry,
Yeah.
protecting India's traditional knowledge,
Yeah.
leadership, directors coming together,
Yeah.
and creating technology day.
Yeah. Yeah.
That was the best.
Yeah.
Isn't it?
Extraordinary.
Extraordinary. The worst, yes, I have a number of moments like that, but I'll put it this way. What has happened is that somebody joked on the other day. They said there is a saying in government: when in difficulty, form a Mashelkar committee. So there have been 16 Mashelkar committees.
Yeah.
Like,
Yeah.
since the students will recognize, my first Mashelkar committee was regional engineering colleges, conversion into National Institute of Technology. And Ravi, I'm very proud. When we did that, I think that if all these changes are made, some of the RECs who become NITs will surpass the IITs. And that
Yes.
is happening now.
Yes.
Among the
Yes.
top 10, as you know, there are.
Yeah.
So, but that has its downside also. Because when you give the committee reports, you please some and you don't please some.
Yes. You talked about Bharat at 100 years of Bharat, or India at that. So that's roughly 25 years from now. 25 years from now, our audience here, I would think, who are there in their mid 20s, they would be in their 50s. at 50s, I would think that they would be at the height of their careers. They would have achieved a lot by that time. So what I would like to ask you is that how do you see the world, and especially the world of science, 25 years from now? And what do you think they should do to make them successful in that world?
Yeah, that's an excellent question. I think first and foremost, what has happened is that we are also living in an exponential world today.
Yes.
The changes are exponential. What we have today, we could not have predicted even 5 years ago.
Yes.
Take ChatGPT. 6
Who
months
knew
ago,
about
we
it?
did not-
Yeah. Who
no,
knew
no.
about it? Yeah.
And they have created a record by getting 1 million customers in 5 days.
Yes.
And 100 million customers, the fastest ever.
Yes, that's
So
true.
as to say, you know. So therefore the changes are so rapid, it's very difficult to predict. But there are some fundamentals which will remain. I think the fundamentals will be the 3Ds. 3Ds being digitalization, democratization through decentralization, and finally decarbonization. These three. And under these there will be various technologies. Okay. Hopefully all the effort that we are doing today on clean energy and climate
Yes.
would result into sort
Yes.
of a better sort of
Yes.
this thing. So I think as far as the new world is concerned, it will be dominated by these diseases. There is no doubt about that.
Yes.
All right. And democratization also is an obvious sort of process. Democratization of wealth, for example.
Yes. Yes. Yes.
As we know right now, because again students are listening, let me say this, that there is what is, I mean, there is a startup movement now, okay. And very quickly, as you know, Exponential.
Yes.
We
yes.
had in 2016 just 450 startups. Today we have 90,000.
Such a steep.
That's steep.
Yes.
Not
Yes.
only that, until 2016,
Yeah.
we used to have one unicorn. One unicorn, for everybody's information, is $1 billion market cap.
Yes.
Okay.
Yes.
In 2021, we had one unicorn not per year but per week.
Yes.
Almost 44,
Yes.
not
Yes.
52.
Yes.
44. But the good news for all of you is that when I did an analysis, I found 50% of that actually comes from not IITs and IIMs, but from tier 3 cities, tier 2 cities.
That I think is the potential that all the youngsters can really display or show.
Yes, absolutely. So technopreneurship,
Yes.
technology
yes.
entrepreneurship. You don't have to seek jobs. You can
Yes.
create jobs.
Yes. Yes.
And so on. And you can just imagine poor farmer's son, 27, 28, having a market cap of $1 billion coming from
Yes.
Shivapur or a Khed or
Yeah.
Amravati
Yeah,
or
yeah.
such a village.
Yes.
So
yes.
this process, the digital transformation, see, I distinguish between digitalization and digital transformation.
Yes.
Because digitalization is doing some part here. There is a total transformation
That's true.
of the
That's
system
true.
that is taking place. I think I can see that in sort of 30 years' time that is basically happening. I think most important point I want to make is that if you look at the society, the first society was hunting society. Then came agriculture, then came industrial, then came information society. So society 1.0, 2.0, 3.0, 4.0.
Yes.
Society 5.0 will be in existence at that point in time.
Yes.
And my only hope is that then we are not just talking about an augmented humanity, but augmented humanism, so as to say, creating that particular
Yeah.
sort of balance.
Yeah.
And therefore, it is going to be a very interesting interplay with the dominance of technology. Like, people talk about metaverse.
Yes.
I gave a talk as Sir Louis Matheson Distinguished Professor on metaverse or metaverse, WRSC.
Oh.
Don't
yeah.
forget that other part of it.
Yes. Yes.
Because when
Yeah.
you have, when you are creating an identity that is not you, if you really start believing in that
That's
and
true.
live that,
That's true.
what will happen to the sort of, so customized identity has its own interesting part that you can
That is
forget
true.
about
That is
your
true.
drudgery and go, but also that. So I
Yeah.
think that society so advanced that that particular balance will be important.
Yeah.
The last point, as I said, there are certain things that will be permanent. I like to end by giving what I learned in my 80 years. And I've learned more by failing rather than by succeeding, I would say. What are those 5 lessons? The first is aspirations are your possibilities. Second part is purpose, perseverance, and passion. The third part, like I said, you keep on knocking on the doors and they don't open. Create your own doors.
Yes.
The next one is that, if someone says it cannot be done, look at it as his problem, not your problem.
That's true. That's true.
That is sort of the point. And the last point is the following, that there is no limit to human achievement, there is no limit to human endurance, there is no limit to human imagination, excepting the limit you put on yourself.
Yes.
No
Yeah.
matter what you achieve in life, you have to say, my best is yet to come.
Yes.
So my suggestion will be, I don't know the age of the audience, but let's say 15-year-old, you will say every day in the morning when you get up, my best is yet to come, and it will come today. And do that if you are 25, 35, 45,
Yeah, yeah.
85, and do it till the last day.
Yes.
So every day in the morning you say, my best is yet to come, not only for me, but for the society and nation.
Yeah.
And 1 billion plus people do in India. Where will India be? Right up there in the Committee of Nations.
Very, very
These are my 5 Mashelkar mantras.
Very inspiring, very inspiring.
Thank you so much. It has been a pleasure, and I'm sure our audience will really learn a lot from it. They will find it inspiring, as I always do, and highly educative. Thank you very much. What a wonderful start to our STEM dialogues. Thank you.
Thank you. Thank you.